Good morning, students. Today's topic is Class P and NP. You all are familiar with this topic in design and analysis of algorithm, right? So, P stands for polynomial time bound algorithm and NP stands for non-deterministic polynomial time bounded algorithm. Okay, so before that, let us see the various complexities. That is, you have big O, big omega, and theta, right? So here f of n is equal to big O of g of n if and only if there exists positive constant c and n naught such that f of n is less than or equal to c of g of n for all n greater than or equal to n naught. O notation to give an upper bound on a function. Right? So f of n is equal to big O of g of n. So you have f of n c into g of n. Omega notation. So big O provides an asymptotic upper bound on a function. Now omega provides an asymptotic lower bound on a function. Okay. So if you see omega of g of n is equal to f of n, there exists a positive constant c and n naught such that c into g of n is greater than or equal to 0 or less than or equal to f of n for all n greater than or equal to 0. The given graph is as shown. Next is our theta notation. So if you see the theta notation, we are bounded to both above and below. Right. So theta of g of n is equal to f of n, where you say that it is between that is greater than or equal to 0, less than or equal to f of n, once again less than or equal to c2 of g of n. These are the three various basic running time complexities. Now, class P. Now, class P consists of those problems that are solvable in polynomial time. More specifically, they are problems that can be solved in time big O of n power k for some constant k, where n is the size of the input to the problem. The key is that n is the size of the input. So, class NP, it is not the same as non-polynomial complexity or running time. NP does not stand for not polynomial. It is non-deterministic polynomial time. Right? Okay, actually it is P stands for polynomial, that is deterministic polynomial. NP is non-deterministic polynomial. So, students, you might think that if T stands for polynomial and NP stands for non-polynomial, it is not so. NP means verifiable in polynomial time. Verifiable. What is meant by that? If we are somehow given a certificate of a solution, we can verify the legitimacy in polynomial time. Okay, so it is also related to automata. Let us see some examples of NP problems. Graph theory has this fascinating, annoying pass of problems like shortest path algorithm, that is a Dijkstra algorithm. Longest path is NP complete. Then you have Eulerian twos, right? It is solvable in polynomial time. Then we have Hamiltonian twos, where we visit every vertex. No vertices can be repeated. In your Eulerian twos, visit every vertex but cover every edge only once. Okay, that is of even degree. Right, so it is solvable in polynomial time, whereas your Hamiltonian twos is NP complete. Now, Hamiltonian cycle. Determining whether a directed graph has a Hamiltonian cycle does not have a polynomial time algorithm yet. However, if someone was to give you a sequence of vertices determining whether or not the sequence forms for Hamiltonian cycle, it can be done in polynomial time. Therefore, Hamiltonian cycles are in NP. Now SAT. A Boolean formula is satisfiable if there exists some assignment of the value 0 and 1 to its variables that causes it to evaluate to 1. Now CNF is conjunctive normal form ANDing of clauses of R's. Now P is subset of NP. Since it takes polynomial time to run the program, just run the program and get a solution. But is NP a subset of P? No. One knows if P is equal to NP or not. What is not in NP? Right? Let us see undesirable problems. Given a polynomial with integer coefficient, does it have integer roots? Yeah, it is undesirable. Okay, undesirable. Hilbert's nth problem is undesirable. Impossible to check for all the integers. It is undesirable. Even a non-deterministic Turing machine has to have a finite number of states to solve a given problem. Otherwise, it will lead to infinite loop. More on desirability later we'll see. Now let us see what is a tautology. A Boolean formula that is true for all possible assignments. Right, so you all know that if for all the Boolean operation, if the resultant state is true, it is tautology. So that is all about class P and class NP problems. Thank you, students.